Okay, here's a video on how to solve problem 31 in chapter 4. This was the one where it was a jump spike volleyball player, and we have an initial height and we have an initial speed, and we're going to do two different problems at two different angles in order to figure out how far on the floor it's going to land. So let's get ourselves a piece of paper to work with. And we're just going to start out by drawing a diagram. So there's the initial height h, and I don't know why I'm drawing it like this. This is supposed to be a person jump spiking a ball at volleyball, but I have it as a ball coming off of a building, but that's fine. And then I'm just going to draw this initial velocity right here, which I'm just going to label as VO, and I can label this as VOX. And I can label this as VOY. And let's get some numbers inside of here if we know. Call that theta 0, I suppose. The height is 2.3. And the initial speed is 20 meters per second. So this is 20 meters per second. And VOX is just going to stay VOX the whole time. It's not going to change, and VOY is obviously going to change. But this we can always write as VO cosine theta, and this we can write as VO sine theta. So that works out. So let's do the first part where the initial angle is 18 degrees. Okay, so we're trying to solve the position. But let's first write our position formula here, which is going to be y equals 1/2 at squared plus v0 yt plus y0. And then I think it's probably pretty standard to say that we're going to call y equals 0 at the ground, and then we're going to have the positive direction as up and the negative direction is down. So that's helpful for us. So that means what we're looking for is first of all, we have to figure out the time that it's going to take for the ball to hit the ground, and then we're going to use that time and plug it into the horizontal equation. So in the vertical direction, we're going to say the ball is going to hit the ground 1/2 negative 9.8, and then t squared plus v0 yt, which is going to be v0 sine theta. So we're going to plug all these things in here. So this is going to be v0 20. I'm going to leave my units off, times sine of 18. And then the time is what we're looking for again. And then I need to make sure that this is a negative value here because I know that it's going in the downward direction. So I'm just going to subtract instead of add, because it's going down, so I know it needs to be negative. And then I'm going to add in our initial height over here, which was 2.3 meters. So this is a bit of a doozy because you're going to need the quadratic formula for it, and what I actually did is I ended up plotting it on Desmos. So here I can show you my plot on Desmos right there, and then I just asked Desmos to find me the root right there, which was 0.3 seconds. So you can use the quadratic formula, you can use your graphing calculator, whichever way you want to do it is fine. So this is going to give me that the time is going to be 0.3 seconds. And now I need to find the x position because that's going to be how far the volleyball is going to go. So we're just going to do x equals v0x times t. Pretty simple. So this is going to be v0 cosine theta times t. So we're going to get 20 for v0, cosine of 18 times 0.3 seconds. And when you do all that out, you get, well, I got 5.7 meters. So that is for the downward angle of 18 degrees right there. And then the next problem says it's going to be for 8 degrees. So we're just going to need to do the same thing for theta 0 is 8 degrees. So we're going to set the whole thing up again. It's going to be really similar to the last time. Okay, and let's see. So we're going to get 0 is minus 1/2 9.8 t squared minus 20 times sine of 8 times t plus 2.3. And then I did this in Desmos also. So there's my Desmos graph for that one. And then let's see, 4.46 seconds. 0.46 is going to be the time. So the time here is 0.46 seconds. And now we just plug it back into x equals v0x times t, which is going to be 20 cosine of 8 times 0.46. And then this time I get my x distance is 3.4 meters. So the change in x, the difference between the two, is going to be, 5.7 minus 3.4. So we're going to get 2.3 meters. Should be the difference between them. Okay, that was a nice one. Not too hard.